Hello, yes, we are recording now. Hello, hopefully this will be the last time I record this video. So this week we're going to be talking about data, how to use data, how to manipulate data, how to use Python to help us understand the data, as well as kind of a brief introduction to Jupyter Notebooks or Python notebooks, and various file types you may run into while dealing with data. So first things first, what exactly is Jupyter Notebooks? I'm gonna keep on calling it Jupyter Notebooks just because that's what I use, but really it's technically a Python notebook. And basically it's composed of cells that can run code. These cells can also create text to like document what your code is and nicely formatted and etc. And it kind of runs everything through something called a kernel, which basically remembers the variables and how you run them. So for example, I've set x equal to 5 when it finishes running. And then if I were to print x whenever it decides to finish running, I think recording this and running it at the same time does not work. Let's see over here. So we can do something here, create a cell, x equals 5, run that, beautiful. Then we can say, print x, and it remembers what x is, awesome. However, if I were to restart the kernel, I'm going to basically be resetting all these variables. So this computer is not going to remember what x is anymore, which is fine, it's good. However, if you make your code dependent on variables and then accidentally delete them or debug something and remove that variable, it won't recognize that variable anymore. And your code will work in that notebook and with that kernel, but as soon as you restart the kernel, it won't work anymore. I don't know why it's not working. Anyway, so that's the notebook environment. In addition to running cells, we have something called markdown text cells, which in Jupyter Labs, it's this, you can sit and mark it down as code or markdown. In Google Colab, I'm running way too much stuff on my computer right now. You can, say by text, add a text cell, and you can add a text cell this way. And basically all the markdown does is an easy way for us to document what we're doing with our code. Basically kind of how markdown works is these pound signs show that we're using markdown and different sides of the text. So single pound sign is a pretty large text. As you get more and more pound signs, the text becomes smaller and smaller. In addition to this, Markdown can do lists, and it can also, with these little backtick marks, can also make stuff to look like code as well. In your notebook, you'll be given a link to other ways to use Markdown, which may be helpful for you, but in general, the code snippet, the lists, and just general Markdown is probably all you need to know for this. So this is Jupyter Notebooks. It's really great. Now, what we're going to be doing with this is, manipulating our data. So first thing, we got to import everything, like one does, and then we're going to load our data sets. Now, we're using a library called Pandas, which is probably the best library to use as an introduction. It does all the hard work for you in the background. Really, all you need to do when you're loading in data is just saying pandas pd.readcsv or read Json or read table, which in this case is a text document. It reads it, it's in there, it's great. So for example, now that it's all loaded in, Pokemon.csv gives us this nice little tabular data. And then we can also, thanks to pandas, get columns. So we're getting the columns, and that gives us an array of all the different columns. And we can do this for other types of data. We can also, find the numbers, and down here it kind of tells us how many and the data type. In this case, we're dealing with integers, which is helpful because this is a numerical data piece. We can also do stuff like, finding the number of unique type 1 Pokemon, which in this case is 18. We can also get the actual list of them. Okay, so there's 18 of them, and this is all of them, which is pretty great. We don't have to like parse through everything. We can just tell it to find the unique ones, and it gives us to it. We can also do basic statistics stuff. So we can find the median by, taking the column we want, HP, and dot median will give us the median. We can also do max, min, standard deviation, variance, a couple other ones if you need them. Super great. And so in this case, our max variable is 255. So that's the largest HP point. And one thing I forgot to mention is that sorry, it is 2 a.m. That it will print out the last line of whatever it is. And if I said like x equals 5, it won't give us anything, but as soon as I do something like this, it will print out the last line for us. So this is why it prints out 255 down here. But we can also do, median, and it gives us a median. Now this only works because this column is numbers and not, strings. So if I were to do type 1, it would give me an error because it's the wrong type. But that is how that works. So we can find, basic statistics, we can find, uniques, etc. We can also do, and this is probably going to be the most helpful, is filter them, kind of like Excel, we want to find everything where it's greater than or less than, this value. We can do that as well here. So first we're going to create an array of booleans by criteria equals Pokemon.csv, the column that we want, and, what we're kind of filtering for. In this case, we're looking for all the values that are greater than the median. And when we do this, we get an array of booleans. We can then take that array of booleans, plug it right back into our pandas data frame, and then create a filtered data frame that contains everything with points greater than the median. And voila, we have this. In addition, so that's the CSV file type, and I will go talk about the file types in a minute. There's another type of file called Json, which is also used a lot in terms of organizing data and structuring it. In this case, when we read it through the pandas library, it reads it as a very similar looking thing. Pokemon JSON. Reads it as a JSON. Did I type that in right? Is the question. Yep. And again, it kind of looks, like a spreadsheet. Notice how the numbers are a little different, and this case the numbers were vertical. In this case, JSON read it as, as the first column. So sometimes you might have to change how everything is read so that it is read correctly by our file type. And then basically we can kind of treat this JSON as an array. So we're going to set that as that. And then we can go like, okay, I want the first thing. So in this case, it grabs the first Pokemon for us and gives us all the stats. And, we can also index because, it's an array. We can index like the values of them and basically treat it as an array. So for your homework, this is probably going to be the easiest way to implement one of your tasks. Basically treating your JSON as an array when you read into it. And then finally, one of the best things about Python is kind of the ease that you can graph things. Whenever you're dealing with data, sometimes it's important to see what the distribution looks like, the most common types of Pokemon, etc. It's really helpful to visualize that information. So in this case, I am trying to find a graph of the average speed of type 1 Pokemon. So basically all I do is I filter out, make sure I get all the type 1 Pokemons of generation 1, and then I create this, array, or this pandas data frame of Gen 1 Pokemon. And then, I want to find the unique ones so I can name the columns or name the X value. And so dot unique gives me all the unique names. And then I'm going to create a list using a loop of, every type, type 1 Pokemon is this first one. And then append it into this array and finding the means of all those different types. Once I have that, I just basically make a plot.bar setting my X value to, the names of the names of the different Pokemon, and the height to, the average speed of each of those Pokemon. And then in this case, setting the data, telling it kind of like where to read the data from the Gen 1 Pokemon. And that gives you this beautiful graph. And then in addition, you can do plot.title, plot.label, X and Y labels, and you can save the figure as, a .png file, picture file, so that you can upload it other places. So this is kind of the basics of graphing. There's a lot in there. In your workbook, you will be given a link to everything you could ever want to know about graphing. Can get pretty complicated, but in this case, just a simple graph kind of gives us a good amount of information about, kind of how fast some of these Pokemon are. So that is how we can use notebooks to manipulate our data. Finally, let's talk about what are these file types. What is CSV? What is JSON? What is text files? So probably the most simple one that you've seen is Pokemon.txt. Looks like this. You open it up, something in Notepad. This is, you're going to get some kind of something that's easily readable. In this case, we do have things separated by commas, which will become helpful in a minute. Basically, text file is your basic file that you're probably going to see other places. And then we have CSV files. Now, Jupyter Labs renders it and makes it look like a spreadsheet-like thing. And if you were to open this up in your operating system, just would open up as an Excel-looking spreadsheet, because that's the easiest way for our computers to present the information to us. However, at the end of it, a CSV file looks just like this. In this case, every comma separates, a separate cell in our data. And so CSV means comma separated values. So in this case, our first Pokemon, its name, its first type, its second type, and then all of its different stats. And basically our reader at the back end of it will look at that and go like, okay, comma, that's my end of my whole data. Now I'm going to start the next cell. So that's how it reads that. And now we have JSON, which is another way of formatting our data so that, our computer can read it and we can use that information to, put it in an app or, tell a website to read it. A JSON means JavaScript object notation. So yes, it says JavaScript and JavaScript uses JSONs, but we kind of use JSONs lots of places, even if we're not touching JavaScript. So JSONs look, actually, VS Code, looks like this. And basically, all they do is they kind of have like this main one, which puts everything in a nice little bracket, like you would see like with Java or whatever programming language you have with brackets. And then, as children of each of that is, our first object. And so that's its number label, number 0. And then, the variables in that object, like name, speed, type, etc. And so basically it kind of stores it in this like object looking thing. And basically, because of that, it's super easy format. So you can just get this, Pokemon and go like, okay, name, type, etc. And it's all easy and accessible. In addition, you kind of use JSONs in lots of places. I gotta move that. There we go. On our VS Code, I don't want to annotate. There we go. On VS Code, we can actually set up the settings in terms of JSONs. So this is how, here's our main root of you know, information, and then inside of it, we're going to set up, you know, default interpreter path to this, etc., etc., etc. So JSONs are kind of everywhere. Sometimes it will deal with, you know, you make a call to a server, you get information from your server, and you get it back in JSON form that you can then populate something in your website. And for Jupyter Labs, is kind of how it looks. A little different, but basically the same idea. So those are the file types. Is Jupyter Notebooks. And that's kind of how we use data and to understand it. Your notebook, in this case, is having a couple different tasks. You're given documentation inside the notebook to help you along your way. If you have any questions, come to office hours. I apologize for this having issues. Hopefully this one will work. If not, I will probably have office hours sometime tomorrow or sometime on Monday and probably Tuesday, because it definitely is helpful to be able to see what's happening on the screen. All right, thank you. How do I stop?